Okay. We'll be looking at another aspect of UNILAG Post UTME mathematics, which is going to be an extension of what you had in the last class. That was yesterday. I'm referring to yesterday where you had indices. Okay. So for today, we are going to be looking at logarithm and solving problems under that. So why I have to take this topic is because when you look at indices and logarithm, they are both interconnected. So if you understand indices very well, understanding solving logarithm problems should not be a problem. Okay, should not be a difficult task. So now, as usual, when we talk about logarithm, well, we say logarithm because as far as post UTME is concerned, it's a thing of speed and accuracy. So we are not going to dwell so much on all of the bases and what have you that are not important. So we take the important ones and we apply them in solving problems. So let's say we have logarithm of a number, say m to base n. Logarithm of m to base n. Let's say the logarithm of this is equals to the logarithm of this. You can get this logarithm from your calculator. Now, the logarithm of a number to a particular base is equal to something. Let me call this A. Where such that the relationship between these three parameters is such that this n raised to the power of A will give us what? M. N raised to the power of A will give us what? M. So, for instance, let me just quickly apply this shortly. Logarithm of 100 to base 10. What is it going to give us? Logarithm of 100 to base 10 will give us, we don't know. Let's say it gives us x. Now, what is not the relationship? The relationship is that the logarithm of a number to a particular base is the number of times the base will be raised to give us back that number. Now, let's leave all of that jargons. Let's apply what I have here. So if you apply what I have here, you can see that the base raised to this guy will give us back the number. So 10 raised by x will give us back what? Will give us 100. So what do you have? From your indices, you know that what 100 is 10 raised by what? 2. So what do you have here? X is equal to what? X is equal to 2. Am I making a sense? So when we say logarithm of a number to a particular base, the logarithm of a number to a particular base is the number of times that the base must be raised to give us back the number. Because 10 raised to a number of 2 will give us back 100. So the logarithm of this of 100 to base 2, of 100 to base 10 will give us what? Will give us 2. But these are elementary. Now, how do we start solving problems under logarithm? We are going to apply the rules that govern logarithm, okay? And these rules that govern logarithm are similar to the rules that also govern indices. So let's look at some of the rules. We have, let's say, log AB, that is logarithm of a number A multiplied by logarithm of a number B will give me logarithm of A plus logarithm of what? B. Am I making a sense? If you remember, yesterday when you did something like this, A raised to power X times A raised to power Y, what do you say to give you? A raised by what? X plus what? Y. That this multiplication will not change to adding up the powers. The multiplication here is also changing to this summation. Okay? Another thing there is that logarithm of A divided by base B will give me what? Logarithm of A minus logarithm of what? Logarithm of B. So division will turn to what? Minus. Multiplication will turn to what? Plus. Rule number 3. Logarithm of A, logarithm of B to base A, where that number is now raised to power a particular power. So the rule says that this C must come down. When that C comes down, that will not be what? C multiplied by logarithm of B to what? To base A. Rule number 4. Logarithm of 1 to any base. Logarithm of 1 to any base will give me what? It will give me 0. Because when I take, according to that rule that we first looked at, a raised power 0 from your indices will give you what? Will give you 1. Another important one is logarithm of, let's say, b raised to power c. Logarithm, the base is also now raised to a power. That is, the number is raised to a power, the base also raised to a power. This will give you what? C over d logarithm of what? B base what? Base a. Now, let's apply all of these rules one by one. How do we apply them? If I have logarithm of 4x, logarithm of 4x, because 4x is 4 times x, is going to give me what? Log 4 plus what? Log x. What if I have log 4 divided by x? That will give me what? Log 4 minus log x. Am I making any sense? And what if I have log 4 raised to power x to base 10? What is this going to give me? X log 4 base 10. Okay? X log 4 base 10. Okay? So all these are the rules that we are going to apply when we are solving our problem. So in order not to waste our time, let's apply this. Some of these rules, a lot of you are familiar with it. Okay? So, but let's see how do we apply these rules in solving problems that is going to and how to approach them for the purpose of your exam. So let's go. Let's go. I have a question here. I have a question here that's going to be my first question. I have a question here that's going to be my first question, which is the question says that log 4 log x plus 5 log x minus 7 log x equals to log 16. 4 log x plus 5 log x minus 7 log x equals to log 16. Now we are asked to solve this problem. Okay. Now the problem says we should find what? We should find x. So how do you solve this problem without wasting your time? Now, if you look at this question very well, there is no base. When base is not given, you can assume that the base is base 10. You can assume that the base is what? Is base 10. When there is no base, because logarithm to base 10 is assumed like is natural. Okay. Okay. So now in that case, what do we do? Now, let me tell you some of the mistakes students will make here. Some students, especially those that are non-mathematics students. What do I mean by non-mathematics students? Everybody, all of you are mathematics students. I'm referring to the art students. They are not, they don't really like math like that. Now, a normal person, you just say, before log x is 4 plus 5 now. We just say this is what? We just say this is 9 log x. That is wrong. By applying the rule, what do we have here? I can change this 4. I can carry it here because there's a rule that says that log 10, log 4 raised by x to base 10 is same thing as what? X log 4 base 10. So I can actually turn this to log x base 4, log x raised by 4 plus log x raised by 5 minus log x raised by what? 7. Am I making a sense? Now, when you have addition turns to what? Multiplication. When you have subtraction turns to what? Division. So what do we have? This can now be log x times x raised by 4 times x raised by what? 5, abi, divided by what? X raised by what? 7. This plus here is turning to this times. Remember, I said that log A plus log B will give us what? Log A times B. And I also said that what? Log A minus log B will give us what? Log A divided by what? Divided by B. So this plus is turning to this times, while this minus is turning to this what? Divide. Am I making a sense? So in that manner, Everything is equal to what? Log 16. So now, this is where you apply your indices. Log x raised to the power 4 times x raised to the power 5 will give you what? X raised to the power what? 9. Because that is 4 plus what? 5. Divided by x raised to the power what? 7. Now, from your indices again, you know that x raised to the power 9 divided by x raised to the power 7 will give you x raised to the power what? 9 minus what? 7. Everything is equal to log 16. Everything is equal to log 16. So what do you have at the end of the day? Log x raised to the power 2. This will give you log x raised to the power 2. This will give you log x raised to the power 2 equals to what? Log 16. Am I making a sense? Am I making a sense? So how do we now go from here? Now that you have gotten to this point, the problem said that we should find x. How do we go from here? Like I told you, that when there is no base that is given, you can assume that the base is what? Is 10. So this is like saying there is a 10 year, there is a 10 year. Now, there is now a rule in logarithm that says that logarithm of a number, let me call the number m, to base a, if it is equal to logarithm of another number n to the same base, this just makes a sense. Because you are saying that log m to base a is equal to log n to base a. It automatically means that that m is the same thing as what? It's the same thing as n. It's not like me saying, oh, the last one of your family is 15 years old. And I'm also saying that, and I know that you are the last one, and I know that you are 15 years old, you are still technically saying the same thing. Logarithm of m to base a is equal to logarithm of m to base n, provided that they are equal, so that this m is equal to this what? N. It's not like saying that you have log a cancel out what? Log a. Am I making a sense? So it's like saying that log 10 cancels out what? Log 10. So what do you now have? X raised to the power 2 equals to what? 16. And from your indices, x raised to the power 2 is same thing as saying what? 4 raised to the power what? 2. So these two can cancel out these two. What do you have? X equals to what? X equals to 4. X is equals to 4. Okay? X is equals to 4. Okay? Now, how do you solve this without wasting your time on the day of exam? How do you solve this without wasting your time on the day of exam? I can actually solve this without wasting my time on the day of my exam by just saying that, although I don't want to go through that way, this 4 log x plus 5 log x minus 7 log x, you can do it in form of arithmetic by adding them together. 4 log x plus 5 log x, what's it going to give you? 4 plus 5, 9. That will give you 9 log x. Am I making a sense? 9 log x minus 2 minus 7 log x. What is 9 minus 7? 2. So you can just say this is what? 2 log x. The only reason we can do this is because all of these things are in the same, they are in the same base. Am I making a sense? If this had been log 5, you cannot add this one. You can only add this and this together. You cannot add this one to it because the base is what? Different. But in this question, no base was given. If no base is given, it assumes that everything is 10. So you can just do it as arithmetic. 4 plus 5, 9. 9 minus 7, 2. So 2 log x equals to what? 16. So look at all of this that we have done. At the end of the day, what do we have? This is going to give you log x is to power what? 2 equals to what? 16. Look at it. I'm here from doing all of this. So, but this is only applicable because all of them are all in the same word, in the same base. Okay? Okay? So, we'll take another problem. We'll take another problem. We'll take another problem. We'll take another problem. I believe this is clear enough. We'll take another problem, and I would unmute you guys so that you can tell me. I want a girl preferably to tell me what I'm to do in this problem. So we have this question. I'm solving 2 questions here. We have the question is solve this equation log.
Sir, I have a question.
Please, okay, go ahead, please.
Sir, you said the bases together, if they have the same base, you can add them. What
You
of
can,
if
yes, you can actually do it. You can actually do it as basic arithmetic.
yes, yes, that's where I'm going. What of if the two has the same base and one have different base? How will you solve it, sir?
What if, like, okay, let's say this one has it has base, it has base 10, abi,
Yes,
and then the other one has something like base 5. Is that what you're
yes,
saying?
yes, yes,
Okay, good. Now, in this sort of problem, you cannot do anything. Because you see, go back to your indices. It's not like me giving you, if I give you x raised to power 2 times y raised to power whatever. You see, y raised to power something. Even if I say I don't want to use y raised to power 2, there's a reason why let's say y raised to power 3, for instance. If you look at this problem, I cannot do anything because that law that applies in logarithm is only bound to what? When they are of the same what? Base. The highest thing I can just say here is that this is x raised to power 2, y raised to power 3. That's all. I cannot come and say that this is xy raised to xy 5. If you have committed the blunder here, because that law is only applicable when they are of the same what? When they are of the same base. The same thing here. In this problem now, you cannot do anything. This is your last point. There is nothing that can be done. As far as this level is concerned, there is nothing that you can do. Okay? There is nothing that you can do as far as this level of mathematics is concerned. There is nothing that you can do here because they are not of the same what? Of the same base. Am I making a sense? Does
yes,
that
sir.
answer your question, please?
Yes, sir.
Now, look at this question that we want to solve now. We have log x to base 2 minus log into bracket x minus 1 to base 2 equals to 2. At this level, nobody will give you a problem where the logarithm are not going to be of the same. There's a question here that they are not of the same base. I'm going to solve it after this one. Okay, and you see when they want to give you problems that are not of the same base, you would see how they would ask you. Now we are now told that you should solve this equation. In mathematics, whenever they say solve an equation, it means that you should find the unknown. You should find what? The unknown. Now, in this question, what is the unknown? The unknown is the x. So now, I want somebody to tell me, are these guys of the same base? Clearly, we can see that they are of the same base. And I can see a minus in between the two logarithm. So if I see a minus in between the logarithm, what should I do? I should divide. Am I making any sense? Am I making any sense? So this will now be logarithm of to base 2. I'll pick the common base because the rule says that logarithm of A minus logarithm of B. I'm assuming that they are of the same base. I will take that common base. I will now divide the first divided by the what? Second. The same thing here. I will take the common base, which is logarithm to base 2, divide the first one, divided by the what? Second one. That's x divided by x minus 1 equals to what? 2. Am I making a sense? Am I making any sense? So now the next thing here is that I'm now going to how do I now proceed from here? How do I proceed from here? How do I proceed from here? Now, who can tell me how do I proceed from here? This will take you back to the basis of logarithm. Before you start looking at laws, understand what logarithm is. I told you that when you say logarithm of anything, let's say A, to a particular base, is now equals to something. The relationship between this A, M, and N, the relationship is that M is raised to power N must give me what? A. Logarithm of a particular number to any base is equal to a particular number that base must be raised to give me back the number. So I have logarithm of x divided by x minus 1. This is the logarithm. So this base is equals to 2. It means that 2, if I apply the same rule now, 2 raised power 2 must give me what? X divided by what? X minus 1. Am I making a sense? And what is 2 raised to power 2? What is 2 raised to power 2 class? 4. Divided by what? X divided by X minus 1. So what's the next thing I can do? Cross what? Multiply. If I cross multiply, what do I have? 4 into bracket what? X minus 1 equals to 1 times X. X. I can open up this bracket. 4 times X, 4X. 4 times minus 1, minus 4 equals to what? X. What's the next thing I can do? Collect like terms. What would that give me? 4X. This will come to this other side, minus X. Minus 4 will come to this other side. It will become what? Plus 4. What is 4X minus X? 3X equals to what? 4. What is now my X? 4 over what? 4 over what? 4 over 3. Is that clear, please? Is that clear? But in the option, you are not saying 4 over 3. Your 4 over 3 is same thing as saying 1 whole number, 1 over what? 1 over 3. Okay? So at this point now, the only thing I just did was I applied the original concept of logarithm that says that the logarithm of anything, this is the logarithm of this whole thing in this bracket. So this base 2 equal to 2. It means that this 2, the base, raised to power this thing, must give me this. Am I making a sense? Am I making a sense? So there's another problem here I want to solve. If you have a question, you can unmute yourself and ask a question. There's another problem I want to solve here, which is question 12. Question 12. Okay. Are we there? Question 12. Now, what do we have for question 12? We have logarithm of 9 base 3 minus logarithm of 3 base 27 plus logarithm of 9 to root 3. This problem now is saying I should evaluate. Evaluate. In this problem, I should evaluate. Now, the boy that asked that question, if you look at these 3 things, are they all of the same base? The answer is no. They are not of the same base. And because they are not of the same base, you cannot apply that rule that we know directly. You cannot say that, oh, this will not turn to divide. This will not turn to times. No. Am I making a sense, somebody? So you have to look at your base. But this is evaluate. So how do we evaluate this guy? We evaluate this guy by, if you look at all these things, this is 9, this is 3, this is 3, this is 27, this is 9, this is 03. You see that there is a way I can always connect them through 3. So how do I go? This is logarithm of what is 9? 3 raised to power what? 2. Am I making a sense? I've changed this 9 to 3 raised to power 2. Minus logarithm of, I still got my 3. What is 27? 3 raised to power what? 3. Am I making a sense? Plus logarithm of what is 9? 3 raised to power what? 2. What is root 3 from indices? Root 3 is what? 3 raised to power what? 1 over 3 raised to power 1 over 2. Am I making a sense? Am I making a sense? So how do we now evaluate this guy? Now there's a rule that says that when the logarithm of a number, the logarithm of 3 now, that 3 is now raised to something. This 2 will come down. That will now become what? 2 log what? 3 base what? 3. Minus, now don't make the mistake here. Look at it. It is the base that is raised to 3. The 3 itself is not raised to power anything, or we say it's raised to power 1. And there's a rule that says that, let us assume that the 3 is raised to power 1, because ordinarily 3 is raised to power 1. So there's a rule that says that if the logarithm that you're evaluating has a power, the base also has a power. Take the base, the exponent of this one, the power of this one, 1 divided by the power of this one. That's what? 3. Because remember, there's a rule that says that logarithm of a to base b raised to power b, logarithm of base c raised to power d is equals to, you very well bring this one out, b, then this will now come under d, logarithm of what? A to base what? C. Am I making any sense? So if I apply that same rule here, I will have 1 over 3 logarithm of 3 to base what? To base 3. Plus, I will apply the same thing here. Look at it. The number we are evaluating, the logarithm of this 3 raised power 2, this 2 will come up. It will come down, sorry. It's coming here. Now, the base is now raised to power 1 over 2. That will now be 2 divided by 1 over 2. Logarithm of 3 base what? 3. But class, because I'm assuming that everybody, we all have a preliminary idea of this thing, logarithm of any number to the same base will give you what? 1. Logarithm of 10 to base 10 is 1. Logarithm of your name to your base name is also going to give you what? 1. Logarithm of anything to the same base will give you what? 1. It means that this log 3 base 3 is what? 1. 2 times 1, 2, minus logarithm of 3 base 3 again is what? 1. 1 times this, 1 over 3. Plus, now, look at this. This is a trick. This is 2 divided by 1 over 2. But you know that from our primary school mathematics, division can always turn to what? Multiplication. When you reverse it, that will be what? 2 times 2. That's what? 4. Automatically, this 2 divided by half is what? Is 4. Am I making a sense? So everything we have here is actually what? Is 4. Okay? So what is 2 plus 4? 6. That's 6 minus 1 over 3. LCM. Okay? What do you have? 6 times 3 is 18. 18 minus 1, 17. Everything here is what? 17 divided by what? 17 divided by 3. Is that clear? Everything there is 17 divided by 17 divided by 3. Is that clear? 17 divided by 3. Okay. So we continue from there. We continue from there. Somebody has a question?
Yeah, please, I did not get that.
I cannot hear you very well, though.
I did not get the law of the power, the switching of the power.
You did not get which law?
The law that says if the base has a power and the power has another power, how you did it?
Yeah, okay. You did not get that principle, Abi. Thank you very much. If the base has a power, the logarithm of what we are evaluating also has a power. Abi, you did not get the law. Okay, good. I will evaluate it now. We have logarithm of, now, this is very straightforward. Understand two things. If the logarithm of what you are evaluating has a power, let me call the power B, the base does not have a power. The base does not have a power. This is equal to, because it's only this one that has a power, this guy will come down. This guy will come down. When it comes down, what does it become? It becomes what? B log A to base what? To base C. That's the first instance. The second instance is when the logarithm of what you are evaluating has a power. The power is B. The base that you are evaluating also has a power. The power is D. The rule says that it's a rule. The rule says that the power of the logarithm of the first of the number you are evaluating, log A, is what we are evaluating. The power of this one will come here as usual. It's coming down like this. Now, this D will now come under it. That will now be B over what? D. Log what? A to base what? To base C. Am I making a sense? Now, let me now tell you something. If you look at your inner eye, come back to this one. come back to this one. The first one that I did where the base does not have a power. If I ask you, that C, if you write ordinary C, ordinary number, you know that from our normal from our indices, if I write ordinary 2, 2 means 2 raised by 1. If I write ordinary C, C means C raised by 1. So this thing here, although it does not have a power, but it has an hidden power. What is the power? 1. So if I now apply this rule that I just did here, meaning that the logarithm of what we are evaluating, log A, has the power B, this one, the base also has the power A. What would this now give me? B divided by what? 1. Please, that boy that asked the question, can you unmute yourself?
Yeah, it's clear.
So what is B divided by 1? B divided by 1 is ordinary what? B, which is what we did initially. So it's very simple. The logarithm of what you are evaluating, its own power, bring it here, divided by the power of the base over the power of the base, which is what I'm applying here. Look at it, log 3 to power 1. The base also has power 3. So this one will come first, 1 divided by this 3, the power of the base. Same thing here. This one will come 2 divided by the power of the base. And 2 divided by half, like I evaluated, 2 divided by half, some of you go and say is 1. 2 divided by half is not 1. 2 divided by half is what? Is 4. Is that clear, class?
Yes, sir.
Is that clear, class?
Yes, sir.
So I want to give you a problem to solve for me now. Let me give you a problem to solve for me. Number 9. Oh, okay. We will not be able to solve that one. There's a typographical error there. There's a typographical error there. Somebody has. So I want you to solve this one for me. I want you to solve this one for me. So I want you to solve this for me. Okay. So we have log. We are told that assuming log log x minus 1 to base 2 plus log x plus 2 to base 2 equals to 2. Class, I want you to solve this problem. I want us to solve it together. So I need you to unmute yourself. So let me just give you an overview because we have very short time left. So are they of the same base? Can somebody respond?
Yes, sir.
Yeah.
So if they are of the same base, it means that I can apply my law. I mean the rule. I mean now.
Yes, sir.
So now, because there is plus here, what does plus turns to?
Multiplication.
Multiplication. Good. So you take the common base, you now multiply. You are multiplying what? The first one, x minus 1. You are multiplying it by what? X plus 2 equal to 2. Now, who can tell me what will I do again from here? What will I do again from this stage? What will I do?
Apply the second rule.
It's not the second rule. You apply the basics. What is the basic? The basics is that logarithm of anything to a particular base, if it is equal to 2, it means that the relationship between these three things is that 2 power 2 must give you what? X minus 1, X plus what? X plus 2. Am I making a sense?
Yes,
Yes.
sir.
What do you have? What is 2 power 2?